Hello everyone. Today in this video we're going to be using Microsoft Excel to show how distribution tables are actually a very simple and effective way to measure central tendency in the form of mean, median, and mode, and eventually we will conclude by calculating the sum of the squared deviation scores and then deriving variance and standard deviation from those. Now let's take a look at our raw data set. In column A, we have dozens upon dozens of values, scores, that our participants have given us in the form of responses. Now, these responses range in so many that it's actually quite difficult to measure central tendency by looking at the raw values themselves. So instead, we're going to take a distribution table. Here in this column C, we have the potential range of scores our participants could have gotten. In the column of D for frequency, we're going to actually measure the rate at which each of these scores occurs, and then using those, we'll calculate our central tendency measurements. Let's go ahead and begin by taking first and foremost the distribution itself. Using Excel's frequency function, we'll go ahead and calculate that out by using the data array and the bins array. The data array is the raw data itself. The bins array are the possible scores that the participants could have gotten in the form of our C column here. Now that we have our frequencies, we can use these to measure out our central tendency. Let's begin with the simplest one, which is mode. To measure mode, we simply look at the highest or most frequently occurring score. In that case, it's going to be a score of 4. We'll go ahead and enter that in here. For median, it's a little bit trickier. Median itself requires a calculation that relies on n. N is the value that represents how many participants or how many scores we had in this particular column. Now we could do that by counting how many scores we have here, or we could look at our frequencies. You see, the sum of all of the f values is your n. Let's go ahead and enter that in over here in the form of n. By taking the total value of n, which is 50, and each individual frequency value, such as 7 or 8, you can also derive the percentages by which those scores occur. For instance, if we were to take 7 and divide it by 50, we would get a percentage that represents what percentage of our participants scored a 1. We could do the same thing for all the other scores and use those to represent the percentages of those scores and to calculate the percentiles by which that score falls. But for now, let's focus on median. To derive median from the frequency table, first we would take our value of n, which is 50, and divide it by 2. The reason we divide it by 2 is because the median is the value that falls in the center. Therefore, if we take 50 and divide it by 2, which gives us 25, and then we count down from 25 using the intervals of each frequency until we get to 0. The point at which we reach 0 will be our median score. So, starting from 25, 25 minus 7 equals 18. 18 minus 8 equals 10. 10 minus 5 equals 5. 5 minus 12 hits 0 and goes beyond it. But the point at which we hit 0 is our median score. Therefore, we know our median score is 4. We'll go ahead and enter that value here. Finally, we'll calculate mean. The formula for mean is the sum of x divided by n. Now we have our n value, but we do not have our sum of x value. We'll need to calculate that. We can do that by simply summing all of our x scores, that is adding them all together, or what we can do is look at our distribution table. Now if you have a small data set, simply adding the scores is easier than taking the product of x and f and then summing those, but in this case, because we have 50 individual scores, it'll be easier to take the product of x and f and then sum those. So let's call this column x times f, and here we're going to take the product, which is the multiplication of x to f. The reason why we are multiplying is because we need to represent that each score occurs many times, literally multiplying. 1 times 7 equals 7. I'll simply use the drop-down of Excel to now multiply the rest, and we could double-check manually for a few. 2 times 8 equals 16. 6 times 5 equals 30. It appears to be pretty accurate. Let's go ahead and now take the sum of all of these scores, which will be the sum of x. We'll call that value sum of x here. And again, I'll use the sum function in Excel to calculate that out. Now we have a value of 189. 189 is the same value we would get if we were to add all of these scores together. Now, let us refer to our formula for mean, which is the sum of x divided by n. In other words, it is 189 divided by 50, which gives us a value of 3.78. Now, if we were uncertain about these values, we could actually double check by using Excel's formula and to convert it there. The mode and the median are simple, but let's double check our mean to ensure that we had the correct mean. Here I'm going to use Excel's average formula and use the original raw data set to calculate that out. We see that we have a value of 3.78, a perfect match. Now, when dealing with Excel, it's easier to use the formulas and calculate from the raw values. But most likely you don't have Excel readily available, and in those cases it's very useful to know how to calculate these measurements using nothing but the distribution table itself. In our next video, we'll take a look at how to calculate the sum of the squared deviation scores and how by using that sum of squared deviation scores, or SS, we can calculate both variance and standard deviation for a particular data set.